Okay, so first of all, thanks everyone for attending our webinar. And for this webinar, we talk about unified streaming and batch processing in RisingWave. Yeah, so this is just some housekeeping items. Yeah, I bet you guys know that we, probably keep muted and the webinar will be recorded, right? If you have any issues with Zoom, please just contact the organizer via chat. All right, let's just get started. So yeah, again, today I'll be talking about unified streaming and batch processing in RisingWave. And I'm Yingjun Wu, and I'm a founder of RisingWave Labs. RisingWave Labs is a stream processing company, and what we are mainly focus is about democratized stream processing. So basically, to make sure that the stream processing is super easy to use, it's affordable, and it's super efficient. And before starting the company, I was at AWS Redshift as well as IBM Research Almaden. I obtained my PhD in stream processing and database systems. So just a couple of slides about what is RisingWave, right? RisingWave is a SQL platform for event streaming workload. And for SQL platform, it means that it can basically it's a SQL database, and it can have the computation. It has the computation layer as well as a storage layer, which means that people can do stream processing inside of RisingWave, and can also store their data within RisingWave so as to serve ad hoc queries. RisingWave is an open source project, and it's released on the Apache 2.0 license 3 years ago. And now we have already gathered around probably 6 or 7,000 GitHub stars, and we have 2,000 Slack community members. If you are interested in joining our Slack community, just welcome to join. We have 2,000 Slack community members discussing how we use stream processing, how we use RisingWave to power their stream processing workloads. And RisingWave has already been adopted by over 1,000 companies, from startups to Fortune 500, for example, Henkel, for example, Siemens, and for example, some other big companies. And these companies are from different domains, from different verticals, from financial services, like banks, like brokerages, like trading firms, hedge fund, and entertainment, including the publishers, well, including the gaming companies, and including the sports betting companies, in energy, manufacturing, marketing tech, e-commerce, and many others. So just to use one single diagram to introduce what RisingWave is. RisingWave is like, so you can see in this chart where you can see that, okay, RisingWave is basically a stream processing system that can continuously consume data from the event buses like Kafka, like Pulsar, like Redpanda, and also continuously consume streaming data from database CDCs. Now we can support database Postgres CDC, MySQL CDC, MongoDB CDC, and several other databases. More than just supporting the streaming load, we also support directly loading batch data from your batch stores, such as the batch stores could be the S3, right? Also could be the Iceberg, and also could be just probably the file system. You can directly ingest this type of data, no matter whether it's from Kafka or from Postgres or from S3, into RisingWave. And the RisingWave will continuously process your streaming data and do joins, do aggregations, do time window functions. And then it will generate the results using the materialized view. It generates results and display it in a materialized view. You can use JDBC REST API or HTTP sync to connect to RisingWave or send the data from RisingWave to some other destinations. For example, some people probably want to use RisingWave to support all their online services, right? In this case, probably you can just use the HTTP sync or probably the REST API. Or if you want to support the dashboard, right, live dashboard like Grafana, then I would believe that probably you want to use the Postgres protocol so that you can directly display your, the RisingWave data to your Grafana or Superset or some other BI tools. You can also directly use for the notebook, such as Jupyter Notebook, to connect to RisingWave, right? Because for example, I believe a lot of data scientists, we actually love to use notebook. And it is very powerful to use a notebook to interactively explore streaming data within RisingWave. And also for feature engineering, if we want to do feature engineering, definitely RisingWave could be the online store. So that's what I mean. You can do the streaming transformation and then transform the features, right? So like you get the features and you send the features to your AI model. So that's what so as to generate the inference, right? And some people will also believe that, okay, they want to store the historical data in some of the data warehouses or data lakes, right? For example, the Iceberg or Snowflake or Redshift. In this case, sure, you can just directly dump RisingWave, dump the data from RisingWave to all these type of analytical systems without using Kafka or some other ETL tools. Yeah. So yeah, RisingWave's goal is to democratize stream processing. So what democratized stream processing mean? Well, what we found here is that for traditional stream processing systems, stream processing system is not like a magic, right? Well, we have already been studied, the stream processing systems have already been studied for over 2 decades. And a bunch of systems have already been invented. But the problem of these systems is that well, they are pretty difficult to learn and they are super difficult to scale, right? Think about the streaming workload. We may come from the workload fluctuation. How we can scale the streaming system from 0 to infinity, right? And more importantly, these systems are also pretty difficult to maintain, which means that if we want to achieve the best performance, we probably need to tune a lot of knobs, right? And this is super painful. So RisingWave design principle is that we just want to be Postgres compatible, which means that well, as long as you know how to use Postgres, the best system every single person I believe will love, right? As long as you know how to use Postgres, you should know how to use RisingWave and how to use RisingWave to master stream processing. And second thing here I want to emphasize is definitely we want to make sure that your stream processing systems can scale, or stream processing applications can scale from 0 to infinity transparently. Right. Transparency is pretty important, which means that you probably don't really want to spend hours or probably even days to scale your system from 1 node to 3 nodes, or probably from 10 nodes to 100 nodes, right? You just probably just want to scale the system within seconds from 10 nodes to 100 nodes, or scale down from 100 nodes to just one single node. RisingWave can achieve that within seconds because of its architecture. And the last thing is that we believe that for stream processing, everyone don't really want to introduce complexity, right? We want to have a system that is basically all in one system. And within one single system, you can do computation, you can do storage, and you can do ad hoc queries. So if you compare RisingWave with the traditional systems, then you will find that if you want to build a streaming pipeline, then typically we want to have a stream processor, Kafka, and as a message queue to send the data between stream processors. And once the stream processor process the data, we also need to have Kafka to send the data from the stream processor to a database so that we can check the results there, right? But with RisingWave, you don't really need to have such kind of systems. You don't really want to have. You don't need to have a stream processor, a Kafka, and a database. The only system you need to use is just RisingWave, because you can just build a materialized views on top of materialized view, so that and then run ad hoc queries to check your results stored in materialized view. That's the magic of RisingWave. And why people choose RisingWave? Besides simplifying the data stack, RisingWave is Postgres compatible, as just mentioned. and people don't really need to spend a lot of time learning what this stream processing is. Right? Well, they only want to know, only want to spend time working on their applications instead of learning how to use a new SQL language or some new Java API, right? It's not what the people want. They just want to use the Postgres experience to interact with the database system. And the second reason for choosing RisingWave is about performance. Performance, well, I have to say that is always pretty important, right? Because for stream processing, I mean, if you want to process for stateless computation like filtering, projection, probably nobody cares because you can probably just write a JavaScript or not a JavaScript, but the Python script or some script or some Java programs to do the filtering and projection. But let's assume that let's think that about for the more complicated scenarios where we want to join multiple data streams from Kafka, from Postgres, from Kinesis, from wherever, right? If you want to join multiple data sources, then you actually need to have a stream processing system that is robust and super efficient. RisingWave, in some cases, we have already supported, in some extreme cases, we have already supported 100-way streaming join. And that case where it's in some cybersecurity company, it's done by some cybersecurity companies. We have already done 100-way streaming join, which is super amazing. And also for stream processing, we care about speedy bootstrapping, dynamic scaling, and instant recovery. Regarding the features, RisingWave has a lot of not just will have I mean conventional stream processing features like watermark, like time windowing, like time windowing can contain the hopping window, sliding window, session window, all these window functions. We have already had that. But beyond those kind of features, we have the schema evolution. For example, if you have the upstream services like Postgres, right? If your Postgres changes your schema, RisingWave can understand the schema change and then propagate the system schema change to RisingWave as well as to downstream systems if you have any. And we also support time travel queries, right? Think about if you want to have, let's say if you want to do some feature engineering or let's say the stock market and data analytics, you essentially want to have the capability to travel back to a certain time point so as to analyze the data there, right? Or analyze the features, right? In the feature engineering use case, you do really want to travel back, and definitely. In that case, time travel is super important, and RisingWave have already support that. And apart from that, UDF is another pretty popular feature. In RisingWave, again, well, I mean, it's a SQL database. Definitely we support a PostgreSQL. But a lot of people are comparing that, okay, probably I want to express something. My logic is pretty complicated, and I do not really want to express in SQL, right? So I probably just want to express in Python, or probably want to express in Java. How do we do that? RisingWave have the Java UDF, have the Python UDF, have the JavaScript UDF, and Rust UDF, and also even SQL UDF. So you can express your logic in any language you want. That's a UDF function. So definitely in this talk, I don't really want to spend too much time talking about what the RisingWave is and how it compared to any other stream processing systems. In today's talk, I will actually more focused on the batch processing and stream processing. What's the difference between batch processing and stream processing? And whether it makes sense to do the unified batch and stream processing in one single system, such as RisingWave. So both stream processing system and batch processing have already been studied for over 2 decades, right? Yeah, let's talk about the batch processing first, right? 40 or 50 years ago, people invented databases like Oracle, like IBM DB2, like Microsoft SQL Server. And then these are OLTP database systems. But soon people find that, okay, we want to do analytics, right? We have a lot of data and I want to do analytics over this large data set. So that's why people invented the OLAP database systems, right? For example, Greenplum, Nutella, well, if you if you heard of the name, and Vertica, right? And then because of the rise of big data, right? People started working on Hadoop. People started working and using so-called the MapReduce style mechanism to process batch data in hundreds of machines, right? And then people also invented Spark. So in AWS, they have the Redshift, and while in some other companies, well, in Google, they have the BigQuery. All these systems are batch systems, and what they do is batch processing. But batch processing is all about for the batch processing for computation, right? Every time we want to every time we want to process the data, we actually need to scan the entire data set and then do analytics. This kind of computation can take probably minutes, probably hours, or probably even days, right? If you still remember the Hadoop world, also the Spark world, if we want to do some offline reporting, it could take 7 days to generate a report, right? But okay, batch processing is definitely super powerful, but in many use cases, we actually don't really want to spend hours or day or even days to wait for the reports, right? We actually want to see the real-time results. So that's why we have people invented the stream processing system. In around 2002, people from the academia, the professors and the students from academia invented the first generation of stream processing systems, such as Stream, Niagara CQ, Aurora, and Boreas. These are the first generation of stream processing systems. These systems are invented for processing the streaming data to support their monitoring application. Because well, let's assume that okay, we want to monitor let's say the telecommunication traffic, right? We definitely want to do monitoring, and the conventional database cannot work in that case. So we actually want to introduce the stream processing. Whenever a new event comes in, we want to check, okay, whether this event is probably a fraud or probably a signal that we should pay attention to, right? And then because of the big data, the rise of big data, people started thinking about, okay, whether we can scale the stream processing system to multiple nodes or to hundreds of nodes, tens of nodes, or even hundreds of nodes, right? And that's why we have the people invented Apache Storm, Apache Samza, S4, and more recently Flink, Spark Streaming, and some other systems. And more recently, I mean, in Kafka community, they believe that okay, they want to process the data in Kafka, and that's why they have the KSQLDB. For RisingWave, we find that what we found is that okay, these kind of systems are all very difficult to use and all very difficult to maintain. That's why we want to invent RisingWave. So okay, these are the history of batch processing and stream processing. Let's think about how the batch will. Let's just use one slide to talk about what's the difference between batch processing and stream processing. The batch processing system like Spark, Redshift, and Snowflake, what they do is that they can batch load a bunch of files, right? Let's say assume that it's a CSV file stored in the S3 bucket. We batch load the CSV files from the S3 bucket into, let's say, Redshift. And then we run a SQL query. The SQL query can probably take minutes or probably take hours. And so in order to generate a report, that's how batch system works. But for stream processing system, the methodology is totally different. We probably can have the data generated from the messaging queue, such as Kafka or such as Google pops up, right? These systems will continuously generate events, and the stream processing systems will continuously consume the events one by one from the upstream systems, such as Kafka, such as PubSub. And then every time they consume the event, they will trigger the computation. Once we trigger the computation, let's say it's probably a join or it's probably a time window function, we will generate the result and deliver the result into either a downstreaming system or a local storage. That's the difference between batch processing and stream processing. So let's take a closer look at our differences. For batch processing, the typical data sources could be files, could be databases, could be S3. While for stream processing, the data sources could be webhook, could be Kafka, and could be Postgres or some other systems. And regarding the latency, for batch processing, the latency could be minutes, hours, or even days. While stream processing, the latency is typically milliseconds or seconds. For the computation model for batch processing, it's all about the full computation, which means that every time we run a SQL query, we essentially need to scan the entire table in order to generate a result. But for stream processing, what it does is incremental computation, which means that every time a new table comes in, it will update the previous result we got from the previous computation, right? That's incremental computation. And batch processing can be used for offline reporting, data science, probably machine learning, all these kind of things. But for stream processing, it's more about monitoring and alerting, live dashboards, feature engineering, right, and many others. And their language, well, I have to say that we're still kind of different. Even though that's, definitely in this case, I only talk about the SQL, right? For batch processing, we use probably just a standard SQL, right? So the NC SQL, right? But for stream processing, we actually have a streaming SQL, which is actually a superset of the conventional SQL. The streaming SQL can contain functionalities such as time window functions, including hopping window, sliding window, session window, and also watermark, right? So that's the difference between batch processing and stream processing. Stream processing in production. How we use stream processing in production? We have already stream processing can be definitely used for financial services. For example, the brokerages, hedge fund, and for exchange payment services. In brokerages, what they do is they want to do the inventory management, right? We'll buy or sell the stock, right? And then we probably really want to monitor the stock, the inventory, right? And because the brokerage is a broker, right? So they definitely want to do a fraud detection. They also want to do the pre and post trade analytics of the live market data. For hedge funds, they probably don't really have too much demand to do the fraud detection or inventory management. What they mainly do is more about the pre and post-trade analytics. And I have to say that post-trade analytics is probably more popular to use a SQL stream processing system. And in the exchange, we have already seen use cases such as fraud detection and commission rebate. For payment services like credit card companies, what they could do is more about fraud detection. And for entertainment, as you mentioned, could be gaming, right? Let's say that we have some companies launching an online game, right? We really want to do the in-game analytics to analyze the user or players' behavior, right? And for sports betting, we want to calculate a live odds, right? That's called in-game betting in these domains. Well, they actually want to calculate the odds in real time, so that we can manage our risk responsibly, right? And for publishers, well, let's say that if I have a newsletter or a newsletter website, we can actually update the taglines in real time based on the user behaviors or based on your readers' behaviors. And for e-commerce, it could be personalized recommendation, price comparison, fraud detection, churn prevention, and prediction, right? And all these kinds of things can be done in stream processing. But at the same time, we can also use these domains, but also need to have batch processing system to do some of the things, right? So that's why people always think about, okay, whether we can do stream processing and batch processing in one single system, and why we can be and can we build such a system? Can we build such system to can we build such a system? Just okay, there's a question. How does RisingWave handle complex stream? Okay, CEP. So this question, some people ask, well, how does RisingWave handle complex stream event processing? So basically, in stream processing, there's a concept called the CEP, the complex event processing, and it will be released pretty soon in RisingWave. And this is pretty powerful functionality. For example, in the energy companies or in manufacturing companies, they actually want to detect, okay, whether there's a pattern, certain pattern, right, to do some certain kind of pattern matching, and whether we can do the pattern matching in real time. And this is essentially a functionality that RisingWave will soon, pretty soon to support. I believe that it will be delivered in the next version, probably to call it RisingWave 2.0. Yeah. Okay. Okay. So yeah, about the unified streaming and batch processing, people were thinking about, okay, whether we can just use one single system to do both batch processing and stream processing, and how can we build such kind of system, right? But instead of just thinking about, okay, building a system for that have a batch engine as well as a streaming engine, we actually need to think about what batch processing, unified streaming and batch processing means, right? When I talk to people, I found that different people have actually different expectations. They actually need different things, and what they really need. We need to first answer this question. Okay, so after talking hundreds of people, I found that there are actually three patterns. The first one is about drawing a batch data, drawing a set of batch data with streaming data. Let's say that if we have a batch data, if we have a batch data table stored in, let's say, S3 or Iceberg, right? And then you also have a streaming data generated stored in buffered in Kafka, right? You probably want to join the Kafka streams, event streams with the batch data, right? So as to generate this library dashboard. Why do we do that? There are multiple use cases. The first one is for real-time fraud detection, right? We probably have the event streams, such as the transaction events from the payment systems. And we also have the historic data, such as the customer profiles, like let's say their name, their age, or their gender, there's some other information, right? Or their last login time, right? And in order to detect whether this event is a fraud or whether it's an event or it's a user whether it's a event that we need to pay attention to, we actually want to join the transaction event with along with the customer profiles or the transaction history, right? That's what we need to do. And the second use case will be personalized recommendation. Let's say that we have the let's say that we have the product catalog and the user purchase history is essentially is a user purchase events, right? We actually want to join the event. Well, I think this is definitely a typo, but we definitely want to join the event with the user purchase history, so as to generate or so as to probably do some better recommendation to your to the user, right? Let's think about, okay, if you log into Amazon, if you search something and browse a website, then Amazon will silently recommend some new item to you. This is essentially where the stream processing system are used. And this is essentially where we actually need to join the streaming data, which is your user behavior, right? And which is your behavior, the browsing behavior, along with the batch data, which is your purchase history. And this is for the personalized recommendation. And think about the dynamic pricing, right? We actually want to change the price based on the user behavior, right? Or our competitors or the price, right? In this case, we actually have the real-time market data and the historical sales data. We need to join these two data and figure out, okay, what's the best price I should put for the product, right? And these are all the use cases about joining a batch data along with the streaming data, right? Join the batch data from S3, from Postgres, from Iceberg, along with the event stream, right? This is a pretty typical use case. And the second pattern we found is about perform batch and streaming transformation using the same code. What means is that people actually have the demand. Some people may have the demand to do the batch transformation along as well as streaming transformation. Can we just use one single system, or that to use one single system to do such kind of transformation so that people can just use one set of code to achieve this goal, right? So there are multiple use cases. The first one I'd like to mention is about the recommendation system. For example, we want to build for example, if we want to develop a recommendation system, we actually need to build a feature, and we actually need to do some certain kind of thing, feature engineering, right? We actually need to transform the raw data into a feature set, and then do machine learning training. And in real time, in production, we also want to transform the real-time events from the raw data into a feature, and then insert a feature into the and send a feature into the machine learning model so as to do machine learning inference. And this is a typical use case for real-time recommendation system. So as you can see, people don't really want to write a set of code for batch processing, and at the same time write not a set of code for stream transformation. We actually just want to use one single system and write one single set of code to do both the batch transformation, to support both batch transformation and stream transformation, right? Similarly, in fraud detection, we actually have the same use case. For example, if we want to do credit card fraud detection, we actually probably really want to use yesterday's data, let's say the last 12 hours data, to train a model, and then continuously consume the events from the real-time events from our Kafka or upstream services, so as to detect, okay, whether this event is a fraud, right? Whether this purchase is a fraud. And in this use case, for fraud detection, we actually need to have to do batch transformation and stream transformation. And what people need is essentially about, okay, whether we can use one single system to write one set of code in order to do both batch transformation and stream transformation. So that's that's a second pattern we found. And the third pattern is more about, okay, performing monitoring queries and ad hoc queries and ad hoc analytics in one single system. Because in many companies, they probably just will use one single set of code to do the okay. So they not only just want to use for the to do monitoring, but also want to analyze the historical data, right? To do some interactive analytics. So whether we can use one single system to support both monitoring queries and ad hoc and analytics, right? There are multiple use cases. For example, for financial market analysis, we actually want to do real-time monitoring of the stock prices and trading volumes. Well, in offline, we actually want to investigate on user trading patterns of the custom time frames, right? And also in the IoT device monitoring, we actually want to do the real-time monitoring of sensor data from connected devices, right? Okay, we want to check whether this a specific pattern or we are interested in evaluation. Okay, there's one question. How do we monitor these real-time events using RisingWave? do we need to set up a client to do that? We actually have I will do a demo after the presentation. So yes, well, I mean, you can directly monitor these real-time events using RisingWave, and you probably don't really need to have a so-called client, because for RisingWave, I'm not sure what client means, but in RisingWave, we actually use we do support all kinds of so-called clients, such as a PG client for the PG shell, right? And some other clients, JDBC, yeah. So yeah, I can do a demo afterwards. So for IoT device monitoring, we actually want to do the real-time monitoring of the sensor data from connected devices. In offline, we actually want to investigate historical sensor data to predict the maintenance needs and improve the device performance. Right? These are definitely very common use cases. And the question is that, okay, how can we do this kind of use case? Well, how can we perform both monitoring queries and ad hoc analytics in one single system? I believe that for all these three patterns, no matter whether it's like, okay, join batch data and streaming data, and like perform batch and streaming transformation using the same code, and perform monitoring queries and ad hoc queries in one single system. All these patterns are pretty valid patterns, and they have strong needs, and people really need that. But I have to say that definitely there's no silver bullet, right? But no matter whether there's silver bullet or not, well, this is what people need. And we do see that in this industry, in the data infra industry, we do see that the modern data stack is kind of like consolidating, and streaming data or streaming system is essentially moving to the batch world, while the batch systems are actually slowly moving to the streaming world. That's a consolidation we need, we find, right? So, for example, in Kafka, a lot of vendors, several Kafka vendors, including Confluent, including Redpanda, including Stream Native, including WebStream, they all mention that, okay, they want to support Iceberg table, support Iceberg format, or they also mention, okay, they probably want to dump the data from the Iceberg dump the data from the Kafka to Iceberg, or probably to Delta Lake. They all claim that. And they also even want to support their own Iceberg format, right? And so as to support analytical queries. Well, on the other side, from the data lake in the data lake vendors, or the so-called lakehouse vendors, we also find that they are moving to a streaming world, right? For example, for Delta Lake, they have already supported CDC, Delta Lake CDC, and the Spark streaming can directly consume the CDC from the Delta Lake, right? That's a trend we have already observed in this industry. So what do we need to do to better support the use cases, to better support the patterns we observed, right? So in RisingWave, what we believe is that, okay, there's no silver bullet in this world. You cannot just, spend, probably how 100 engineers to develop a huge system that is good at both perfect at stream processing and batch processing, right? It's not, and to support all these three patterns, it's not realistic, to be honest, because there's no silver bullet, and these design principles are totally different, are drastically different. So, but in RisingWave, our goal is to be the best in class streaming first data stream processing system platform, which means that RisingWave is essentially what we have is the world's best SQL streaming processing capability. And in the meanwhile, we want to make sure that, okay, we are good enough for batch processing. And we want to make sure that RisingWave can support most of the use cases in one single system, most of the unified batch processing can all satisfy most of the unified streaming and batch processing need in one single system. So how do we do that? So let's talk about the joint batch and streaming data first. So let's say that we have a you have a streaming data coming in from Kafka, and at the same time, if you have a batch data stored in S3, right? In RisingWave, we do support connectors for, we do support continuously ingest the data from Kafka, and at the same time, you can also generate load the data from S3. And essentially, RisingWave support two load methods. One is called batch load, and the other type is called streaming load. For batch load, it means that we just load the data once and only once, right? So that once we load the data into RisingWave, it will be a table. It will be just a normal table, and no change will be made. Even if you change the raw data, right? Or even if you change the raw data stored in S3, RisingWave will not consume the changes, right? And at the same time, we support the streaming load. Streaming load works totally different from the batch load, which means that streaming load actually allows people to load the data continuously, even if it is stored in the batch data source, for example, S3. Let's take a S3 as an example. If you have a bunch of CSV files stored in S3, RisingWave actually can load the data continuously. It will load the existing data in one batch. And once you put more CSV files into the S3 bucket, RisingWave will essentially identify these changes through the S3 notification and apply this and then consume the delta or consume the changes into RisingWave, load the new files into RisingWave. This is a continuous load or the streaming load, which means that the RisingWave data or the data stored in RisingWave will be always consistent with the batch data, right? So, and for batch load, we have reached support for S3, Postgres, Iceberg, and we're pretty soon support the Delta Lake. Well, in the streaming side, for the streaming load, we have reached support S3, Postgres, and we're soon support Delta Lake. But for Iceberg, well, because Iceberg doesn't really have CDC in the plan on their roadmap, we could not really consume streaming data from the Iceberg. That's a limitation of the Iceberg. So definitely, if you want to pick a data format, or if you want to take an open data format, you probably also need to take this into consideration. And the second use case is about the second thing I want to talk about is how we can do batch processing and batch transformation and streaming transformation using the same code within RisingWave. So let's say that we want to do feature engineering within RisingWave. How do we do that? Can we do batch load and batch processing, batch transformation, and stream transformation in RisingWave? Yes, you can do that. So RisingWave right now support a mode called the streaming, support a processing mode called the streaming processing mode, which means that every time a new event comes in, you will generate a result, right? But pretty soon we will actually support a new mode called the batch mode, which means that we will not evaluate the query instantly, and we will do some batching. And so that you can essentially consume the batch of data, do batch transformation, and then periodically do batch transformation, and then send the result into downstream systems or just storing in RisingWave. So okay, what's the limitation? Okay, Flink. Okay, I can answer this question later. So the question is about what are the main limitations of Flink in acting as a unified streaming and batch processing tool, though it has been trying to achieve this over the last decade. And I'm also interested in how RisingWave addresses this limitation. Okay, I will answer this question later. Okay, let me finish this. Well, right now, what you can do in RisingWave is that, let's say that if you want to process streaming data and the batch data, you can actually use for for stream processing data for stream processing mode. RisingWave have already support that. And for batch mode, what you can do right now in RisingWave 1.10, which was released yesterday, what you could do is that you can actually use Airflow or some other orchestration tools to orchestrate a workflow, right? We'll probably do the trigger every 6 hours. You can do that. But for pretty soon in RisingWave 2.0, we will essentially release a new mode called the batch mode, which means that with the batch processing, which means that you don't really need to use any orchestration tools, and you can just set the freshness or set the computation frequency within RisingWave, and that's so-called batch mode, and we will support that pretty soon. Okay. And the other one is about the third pattern we mentioned is about the join batch and streaming data. Sorry, it's not join batch and streaming data. So basically, it's about do the monitoring queries as well as ad hoc queries in one single system. Again, RisingWave is a database system and it can store data. It also has a batch engine so that we can do ad hoc queries in the batch engine. But definitely, I'm not trying to claim that RisingWave is a data lake. It's not. Well, it's not definitely not at the moment. It's not a lake house. So if you have a tons of data, then the best practice would be like, okay, you have to store this batch of data in probably some data lake, such as Iceberg, such as Delta Lake, or probably you can use some commercial systems such like Snowflake or Redshift, right? You can definitely do this. But one thing I want to highlight is that if you want to store data, in RisingWave, we can seamlessly send the data from RisingWave to continuously send the data from RisingWave to Iceberg and Delta. And at the same time, RisingWave can actually perform ad hoc queries on Iceberg. And as we measured internally, RisingWave's performance is actually better than some of the world's best ad hoc query engines. And we will probably write a report on that pretty soon. So in this case, you actually don't really need to have a query engine like a SQL query engine to do federated query in the future. You actually can just use one single system, that is RisingWave, to perform both stream processing and ad hoc queries over Iceberg or over Delta Lake. So, okay, I can do some demo. So before doing some demo, I can address the question. Okay, what's the main limitation of Flink in acting as a unified streaming and processing tool? So for Flink, well, Flink is a pretty good unified streaming and batch processing framework, and it's not a database, so it doesn't really have the storage engine. So I could not say that it's like I would like to say that probably Flink is better for doing join batch and streaming data and for the batch and streaming transformation. But the two things that are pretty different. The first one is that Flink doesn't really have the storage. So doesn't really have the storage. So that in order to join the batch data and streaming data, it actually have to continuously do lookup joins. Well, there's a term called lookup join, which means that you actually need to host, let's say, a serving system such as Redis to host your batch data here, and then do the streaming join, and then do a streaming join. Every time a new event comes in from Kafka, you actually need to send a system call to query the data stored in Redis. This could be very expensive, right? But the difference between RisingWave and Flink in this use case is that RisingWave can actually store data inside of its own storage. As you can imagine, it can avoid a lot of network traffic, which is super expensive in AWS or any other systems. And by allowing people to store data in their in RisingWave internal storage, it can definitely achieve way better performance because definitely there's no network traffic, right? And in this use case, for batch and streaming transformation, So one point I want to make is that RisingWave is Postgres compatible, which means that RisingWave is like it has a super rich support for SQL semantics. And as long as we want, let's say that if you want to do some JSON transformation, if you want to do some fancy joins, you can just use RisingWave using the same code for Postgres with Postgres-style SQL. But for Flink, well, I believe that for their Flink SQL is kind of like, yeah, it's not like a standard SQL. So probably you need to figure out, okay, what's the difference between their batch SQL and streaming SQL. But in RisingWave, it's like a same SQL, Postgres SQL. That's the difference. All right. Okay. So now let's do a pretty quick demo. Yeah. Yeah, this is a RisingWave cloud, and so everyone can just register and use the so-called trial trial project. And so what we can do is that, okay, let's say that what we want to demonstrate is that how we can join a RisingWave table with a stream. Let's say we want to join a Kafka stream with a batch table, right? We can just enter the workspace and click the jump stop query. Let's say that, okay, let's do something like, okay, within your Kafka stream, okay, let's do this one. Join a Kafka stream with a MySQL CDC. So basically, what you can do is that in this case, the first step we will do is that we will create a table to store the events coming from Kafka. Okay. The only thing you need to do to ingest the data from Kafka is that you can just use a statement called create a table. And in this case, we will have 4 columns: user ID, add ID, timestamp, and event tab. One thing I want to mention here is that if you have a schema registry like Confluence registry or Repanda registry, you actually don't need to list these columns. RisingWave can actually parse their the registry data, registry information, and infer the data, yeah, basically extract the data type directly without will extract the data, the column name and whereas a column type directly. Okay. Okay. So this after clicking this, well, we can create a table to store the add event coming from Kafka. And then let's say that we want to consume data from CDC, right? Or from MySQL CDC. What we can do is just create a source, right? So the create a source statement will help us to create a CDC, start consuming the CDC stream from MySQL. And then let's think about let's consider, okay, how we can create a table to subscribe the dimension table from the, okay, let's create a table, right? And then create another table called myAdd, right? So in the last step is that we want to get a real-time number of the add impressions for each product. Let's try this out. So, okay. Okay, now we get a result, right? So as you can see, we can essentially, the RisingWave can continuously consume the streaming data from both Kafka and MySQL. And the only thing you need to do to connect to your MySQL and Kafka is to create a table or create a source. Or you can check out docs to understand what's the difference between the source and the table. The main difference is that, okay, sources will not persist your data in RisingWave, while table will persist your data within RisingWave. That's the difference. And okay, and then let's say that we want to refresh result every 1 single minute, and you can see some data refresh here. Yeah, the results refresh here, right? You can also visualize the data. Yeah, you can also visualize the result here. So yeah, this is the result we got in RisingWave. So definitely RisingWave is not just limited to do the string join, right? Let's say that we want to do some other fancy things like, okay, let's just take another demo about, okay, explore from send the data from Postgres-CDC to Iceberg, right? So in this case, if you want to send your data from Postgres to Iceberg, the only thing you need to do is that you need to create a table called add event, right? In order to connect to your, okay, this is Kafka. Okay, hold a sec. So let's try this one. Okay, the Postgres. So the first thing you need to do is that you want to create a source, right? To declare that you want to connect to this data Postgres table. And it seems that I have already connected to this Postgres. Yeah, I have already connected this Postgres CDC in the past, so you cannot do this anymore. But I can just change the table source name to Postgres CDC 1, and now you can see that it works, right? And then the second step is that, okay, let's say that you want to create a table in order to do some projections from the CDC, right? See that, okay, it exists, right? Okay, it's successful. And after that, you want to extract some other columns from another database Postgres table called public purchase. Now we have already had the database table called PG product and PG purchase. Now we want to create a materialized view, right, to calculate the top selling groups. With this rule step, you will generate a materialized view containing all your top selling items. And then now you want to send the result into Iceberg. So how to do that? The only thing here that because in this case, I do not really have an Iceberg table, but the only thing you need to create is that you only need to do is that you can just use this statement called create a sync Iceberg from your materialized view, and then put your S3 the S3 information here in this statement. Okay. Cool. Yeah, that's a demo I have. So okay, back to our slide.
Yep, we are running out of time, so I'm asking everyone to stay a few more minutes.
So yeah, that's all I have. And if you have any questions, feel free to ask. And or probably you can just DM me or ask in our Slack channel. Yeah.
Yep, good idea. Join our Slack channel. The link is in the chat if you want to continue this conversation with Yingjun and everybody else on the team. And if there are no questions, thank you, Yingjun, once again, and thank you everyone for attending.
All right. Thank you. Yeah.
Have a nice day. Bye.
Yeah. Bye.